Thank you, Madeline, and welcome everybody. Thanks for joining us today. I've also got my colleague joining as well, Vicky. So a couple of housekeeping things. There's a chat box, so if you guys have any questions, please feel free to enter that into the chat, and then we will address those at the end or throughout. Vicky may be able to address some of those as well as we roll through the presentation. So we've got a lot of ground to cover, so I don't want to take too much time on introductions, but again, I'm Dan Glazer. Happy to be here. Thank you, Soligent and Madeline and everyone on the team for allowing us to present today. We wanted to really, I think in the last year, we're finding that there's still just a lot of kind of fundamental education and a lot of misinformation and just kind of lack of education out there in energy storage. So we're going to touch on some basics. And these basics will apply to not only our EverVolt system, but to any energy storage system out there. And then also dive into some of the deeper fundamentals and really just focus on trying to simplify, the sale and the product itself. So we will go ahead and get started here. So this is the agenda. As you can see, we're going to talk about, again, essentials and dive into EverVolt specifically, talk again about some of the sales and design strategies that we've seen people have success in the field. And then our favorite topic, whole home backup. So fundamentally, there's been an evolution in energy storage systems over the past, probably at least 30 odd years or so. The traditional way was having a customized solution. So as an installer, you generally, at least when I first started in solar, you either were very familiar with energy storage and off-grid systems, and you had deep knowledge, or you just stayed 100 feet away from the stuff and never wanted to touch it because it was very complex. So you wanted to not only right-size system design, but you had to piece together components oftentimes. So that meant different inverters, maybe piecing together the charge controller, the different batteries, cabinets, all types of different components in an energy storage system had to be pieced together and in a custom fashion. So, there are some advantages to that, of course. You can specifically right-size a system. So you can really dial into the amount of kilowatt hours or kilowatts that you need. And then if you have, if you're very comfortable with a certain brand or product, you can choose to use that within that system and then use other components in the system as well. For example, a different inverter manufacturer compared to a different battery manufacturer. The downsides is you do generally then have warranties by different companies. And so there are different lengths of time for the different components. You have different entities to deal with throughout that system lifetime. So it can be a little bit confusing and challenging. As I mentioned, is very, I would say, advanced level of design and knowledge required to do that, not only just from piecing together components and sizing things, but on the installation side as well, and programming and all kinds of complex things that installers will have to learn just over time, simply. And then generally a custom system is not going to have UL 9540, which is not a requirement in all jurisdictions right now, but we're seeing it pop up certainly in California. And for sure it will be applicable across the country over the coming years. And then again, a lot of times if you're piecing it together, you have to, every battery and every inverter has kind of unique designs and parameters. So if you even if you have an inverter of choosing different batteries, you have to kind of know and dive deep on the battery to program that into the inverter. So over the last couple of years, there's definitely been a shift to more of standardized systems. So this is kind of the complete package, which is what we're providing today. And it's very simple. So the number of advantages here you can see are a little bit greater, we think. So you have support and warranty by a single company. So from a homeowner's perspective, they don't have to worry about their investment and who they're going to go to for where, and similarly from an installer's perspective as well. It will generally have a UL 9540 certification. So that again is the system certification. The components are all UL certified. So the inverters, the batteries, all of those will all have their own individual UL certifications, but the 9540 is the complete system level certification that says these components essentially work and are compliant together. It's some very simple design, purchasing, installation, which you'll see here. And then this is actually pretty key, is you have full system specs provided. So as I mentioned, inverters are different than batteries, and the specs and the amount of power that each of them produce is different. So you have to kind of have a really good knowledge understanding to marry those two together to provide what the system is actually capable of to a homeowner. So by buying a standardized system, we provide those specs, and it's very simple and straightforward. Now, the downside to a standard is obviously it's a fixed system size. So you can't dial in exactly to the number of kilowatt hours of battery you may want. And then also sometimes there's giant units or larger units, heavy, things like that, that may make it difficult to install or service. But I think we're seeing, and the industry is seeing, that these downsides generally, the upsides are much more applicable, and folks are moving more towards the standardized system. So just on the basics level, again, I won't talk too much about this because I think we covered it for those of you that were on our webinar, or any of our webinars previously. But you have kilowatts, that's the power. Kilowatt hours is the tank, essentially, of how much energy you have. And so how do you get energy to and from your house loads, or to and from the grid, or from solar into the batteries? That's through the inverter. So the inverter is going to control how much energy you can both input to the batteries and extract from the batteries at any given time, which from a practical perspective, that's how many loads you can power in a home at once. So our system, EverVolt, it comes in both DC and AC coupled versions. So this is a very simple DC coupled system. So you have on the left, you have our EverVolt inverter. That's the little picture with the brain on it here. And then to the right of it is the battery cabinet. And so that entire package will come with EverVolt. So again, you don't have to figure out what components are where, or piece together things. But in a very simple DC coupled layout, you've got the solar PV array that's connected directly to the inverter. And then you have your grid connection, which you see here, just going to your main service panel. And then you have your loads connection, which is going to your backed up loads panel. So this is, kind of the ideal way to do things, because you are going to be providing power to those backed up loads in a grid outage situation or emergency situation. And you can design it and only put the loads on there that the system can support. So you'll never risk overloading the system. This is an AC coupled design. So you'll see here, we've got our EverVolt system on the left, which you'll probably notice that this is in white. So that's an easy way to tell. AC coupled is white for us, and then DC coupled is the black enclosure and inverter for us. So similar, you have your grids connection, no change there. You have your loads connection, no change there. Now, obviously the big difference is we're not taking PV directly into the inverter. So you have your separate PV inverter. It can be a string inverter, string inverter with optimizers, microinverters, whatever is you're choosing, and that is connected to the backed up loads panel here. So in the case of a grid outage, you have your solar still running, and your PV inverter is feeding those backed up loads, and then any excess is also going to our system and charging the batteries. So fundamentals, again, AC versus DC coupled. We've got DC from the solar, DC in the batteries. Our home loads use AC. So what are some great reasons for choosing a DC coupled system? It's simple. You've got one inverter. So as you saw previously, it's very easy to design. It's great for new PV systems. If you have a blank canvas, a DC coupled system will be able to control the PV and kind of move power back and forth throughout the system more intelligently and more efficiently. It's slightly higher efficient than AC coupled. Now, I kind of emphasize the slightly higher because, yes, in general, DC coupled systems are higher in efficiency than AC. Quantifiably, at least on a residential level, that's very subjective, because there's a lot of other factors that come into play as far as what is the true conversion efficiency on the system overall. So, in general, we just say DC coupled is more efficient, but it's not the end all be all to system design for residential, at least. And then DC coupled, you're going to have better control over the PV array, again, because that DC solar system is connected directly to your array. So we're controlling the MPPT points on there. AC coupled, on the other hand, why would somebody choose that? So it's great if you already have a PV system on the house. Obviously, you don't necessarily want to rip out the old inverter and replace it. So you can just throw on an AC coupled EverVolt system. It's great. It's a different O&M strategy too. There's obviously a lot of people that use AC coupled for brand new systems. So kind of one of the different strategies there. It's different for O&M. We all know, those of us that have been in solar a long time, really the only thing that ever truly goes bad on systems are inverters. So from an O&M strategy point of view, in an AC coupled system, you're going to have multiple points of failure. So in a DC coupled system, whenever that inverter does eventually fail, your whole entire system is down. In an AC coupled system, when that inverter fails, or it might be the PV inverters that's failing, or microinverters, whatever is failing, but your battery system's still up and running. So kind of different approaches to O&M philosophy. And then again, it is AC coupled because you're transferring power from AC to DC and back and forth more. It's slightly lower efficiency. But one of the key things too to AC coupled, it's just easier to sell, design, and quote. There's a lot of customers and installers and homeowners that prefer either microinverters or optimizers, or they're just very comfortable and they've been designing with those types of inverters and systems for a long time. So AC coupled, you can simply do an adder to those systems. You don't have to redesign the system or know how to necessarily string an inverter. So these are the basic components of EverVolt. We've got our Panasonic 18650 battery cell, which is also widely known as it's in many electric vehicles. And these are inside of the battery module. There's 351 of them in each pack. And then inside of each enclosure, you have anywhere between 4 to 6 of these battery packs. Now you can see that dimensionally, we do have a very thin profile. So we only stick out 10 inches from the wall. And this is really key in a lot of jurisdictions that are cognizant and aware of clearances around vehicles, and they have certain requirements of having garage space. So it's very nice having got a slim profile unit that doesn't take up a lot of real estate on the floor. Now these are our SKUs. As I mentioned, we're taking a very simplified approach to energy storage. We want to give people the most, the best solution. And so we've married different sizes of batteries and inverters together to give the best package. So you have really only a couple options. You have either AC or DC coupled, which we talked about. And then you have either our standard or our plus. And the standard, it's simply 11.4 kilowatt hours of usable energy, and the plus is 17.1. Now you can stack systems. So if you do need more than 17.1, you can buy an additional unit and connect them together, and that will increase the energy capacity and also increase the power output to the loads. So these are kind of a recipe book of mixing and matching systems in a sense. You'll see we've got our EverVolt standard all the way on the far left, and then next to that is EverVolt Plus. And then we start stacking systems to the right of that. So we have 2 standards, or you can stack a standard and a plus, 2 pluses, or up to 3 pluses. So you can see the power, and this is the kilowatts that are going to the loads. So during a grid outage, this is what would be available. You have your backup current below that, and then you have, again, your energy capacity available. So, one of the things we've seen successful is to try and simplify it in your mind. And when you're explaining to homeowners is, really the standard and plus, it's something that we like to call kind of the essential home backup. So this is, again, we're installing the sub panel, you're putting 120 volt loads on there, single pole breakers. And, you're not going to be charging your EV in this configuration. You're not going to be running your AC, powering well pumps or anything like that. In general, at least, there are some exceptions, of course. And then kind of this group, we like to say this is partial home backup. So we're talking all your single pole breakers. Maybe now we get into some things like smaller AC units, smaller pumps, things like that as well that we can throw on there. Or, if you just simply have a larger home. And then finally, with the kind of the king size, or what you want to call it here, is the main service panel backup. So this is where we can do 3 systems. You can see the power output starts to get pretty significant. So we can handle, certainly most 200 amp service connections and kind of back up essentially a whole service panel in most cases. So these are the SKUs. Again, so when you're ordering, you just order that SKU and it will come with everything that you've seen previously: the inverter, the battery cabinet, the batteries, all the wiring components, and everything that you would need. So now these are the system level specs. So these are the 2 different model that we mentioned, the standard and plus. Now, something very key that I think a lot of folks and even utilities that we speak to They don't necessarily understand this when they look at spec sheets from people like us or other energy storage manufacturers, is even though we have different power available to the backed up loads, the inverter in our system, to the grid at least, is a 5 kilowatt inverter. So that means that we can only at maximum send 5 kilowatts of power back to the grid. Now below that, you'll see to the backed up loads during an outage, we can provide more than that within the home, but to the grid is 5 kilowatts. And this is important in certain jurisdictions or with certain utilities that have caps of how much power you can send back to the grid. So for example, sometimes they cap it at 10 kilowatts. So by using 2 of our stack systems, even though we can provide over 10 kilowatts to the backed up loads, we're still meeting that 10 kilowatt threshold to the grid. And then you see the efficiency here, and then operating temperatures and storage temperatures below. And then the battery cabinet on the right, that is with the cover removed. So it's simply you have 4 packs there. That's the standard. And then if you have a plus, there's just 2 additional battery packs on the top. So the basic design philosophy of AC coupling, again, this is what we showed previously, but let's say the grid goes down. So now what happens? You've got the sun shining. It's a great, I'm in Southern California, sunny Southern California day. You've got the PV inverter that's cranking out, let's say 5.5 kilowatts of power to the backed up loads panel. And now our batteries in a plus system, they can accept that 5.5 kilowatts. So life is good. And that's even with no home loads on. We're charging the battery. If the battery reaches 90% in this case, when the grid's down, we would simply shift the frequency and turn that PV inverter off. So this is the basic design. So this would be for older inverters if you're retrofitting something from several years ago or beyond that is not a newer inverter, then we treat it in a pretty binary fashion. So it's kind of on off if we need power to the batteries. Now this is a newer AC coupled system with frequency control. And so this would be a brand new inverter per se, something that's been installed in the last year or two and has this capability. It's a UL 1741 certain requirement there. So here the grid goes down. Again, sun is shining bright. And let's say in this example, we have a larger PV inverter, 7.6 kilowatts are going to the backed up loads, and our battery is taking 5.5 kilowatts of charge. Now you see there's a differential there. So where's the extra power going? We don't have the grid, so we can't send it to the grid. And now let's say we do have 1 kilowatt being consumed by home loads. But what we're able to do here with frequency control is we can, if we're getting too much power, we can start to shift our frequency. And so we can have the PV inverter essentially react to that and throttle its power down. So that way we don't have to completely shut it off like we do with an older system. So just some basic sizing considerations. Again, size it with the sale of PV, not after the fact, because there are some limitations as you'll see here. So with older inverters, our general guideline is you match it to what the battery can accept on a charge, which you'll see here is 4.6 and 5.5 for standard and plus. Now for newer inverters that have that frequency control capability, we say 7.6 with a solar edge per EverVolt system, or 6.5 kilowatts of AC power with Enphase or others per EverVolt system. And again, that's AC power. So, it doesn't necessarily mean that's how many panels you have or your wattage on the panels, or necessarily even the wattage of what the inverter is. It's really what the system is able to produce in any given time throughout the year. DC coupled, obviously the PV is going directly to the inverter, so a little bit different. We've got 1 EverVolt, we can take 6.5 kilowatts of DC. And so this is based on the number of modules then. And actually something we're going to be releasing here in the next, before the end of the year, is a firmware update that's going to extend the capability of the 6.5 up to, I believe, around 8 kilowatts per system, or perhaps even greater. So that's coming. And then 2 systems is obviously 13, and then 3 is 19.5 kilowatts of DC. And so again, you can stack systems. So by 2 EverVolts, you get up to 46 amps, 3 EverVolts, 69 amps. Now these are the 3 golden rules for stringing on the inverter. So for those that have been doing PV design since perhaps before the microinverter and optimizer days, you'll remember that how to string size, hopefully. So if not, we've got definitely some assistance we can provide to help train and educate you guys on that. Something fairly unique to EverVolt, and we get a lot of requests actually for this, is generator integration. So the way that the system was originally designed is there is an accessory kit. We call it the AC relay kit. And if you want to integrate a generator directly with our inverter, you would just buy this kit, and that's what you see these wires connecting to inside the inverter. It just mounts on a little DIN rail in there. And the generator can be connected there. And really what this is the backup to the backup is kind of what we call it. So it's not meant for daily use or regular use. It's really just for a homeowner that doesn't want to buy a second or third EverVolt system, but they do want to have the additional resiliency and are concerned in the situation where their batteries might be completely drained. So what happens here is if the generator has auto start capability, we can auto start that once the batteries will reach 10% state of charge. We can auto start that generator so that it takes over from what the batteries were doing. So that way the homeowner doesn't lose power after the batteries are drained. And then simply we would have the batteries or the system come back up when the grid comes back, obviously, or the next day when solar comes back. So this is kind of the basic wiring diagram for integrating that generator. I won't dwell too heavily on this here. We can send this out to you guys after. Now there is a second method that is not officially designed by Panasonic, but certainly we have some installers that say, hey, I've got this customer, they really want to have the ability to charge the batteries, directly from the generator when the grid's down. And so they've actually gone out, purchased third-party equipment for charging batteries. And you can see it's kind of wired like this, where you have the generator and then there is an inline device, a battery charger in between the battery banks and the generator, that then they're in a true kind of emergency or outage situation, they are using that battery charger to charge those batteries. Now we are working on a firmware, we're actually beta testing it right now, that will allow the generator to charge the batteries natively with EverVolt's system without having to buy that additional component. So that should be officially launched early Q1 next year. Just a caveat to all of this, of course, is charging batteries not from solar can have implications to incentives and ITC and things like that. So always, make sure you're knowledgeable about that. Check with the homeowner and tax representative and all of that fun legal stuff. All right, so I think we've got the fundamentals. So now how do we take all this knowledge and deliver it to a homeowner and in an easy, simplified manner? And then, obviously get them to close the sale at the kitchen table, hopefully, or very soon thereafter. So number one sales strategy, I would say, is setting the expectations with the homeowner. We get installers, and again, installers, I think, pretty much on a daily basis that haven't done this with the homeowner. So the homeowner, because of Googling they've done, other energy storage systems, marketing that they've seen, they say, yes, I'm going to buy energy storage. It's going to back up my entire house. I can run things. Life is good. But really, that's not the reality of the situation, because all systems, not just ours, but any system that's comparable in the price range, is going to have its limitations as far as amps and power to the backed up loads. So off-grid is generally not an option. Of course, homeowners love to, especially in these crazy times we're in, say, yes, I want to cut the cord. I want to go off the grid, build my dream system, which I think is incredible and a great aspiration. But then when the reality hits the bank account and you don't get the ITC or other incentives, and you have to tell them, well, sorry, you're going to have to remove the jacuzzi and all these other items. Again, it's not really an option in most cases. Whole home backup, similarly, is not generally an option, because if you truly want to back up, again, either a 200 amp main service panel or oftentimes 400 amp or larger, you need to get a lot of batteries and a lot of inverters. And it's certainly possible. We've done systems like that and we've seen systems out there, but it's the exception to the rule again. How big of a system can I afford? Our philosophy is whatever the budget is, maximize the amount of energy storage, because this is a a minimum 10-year investment. We know the system's going to last much longer than that, but minimum 10 years. So that's a long time. So make sure it's going to meet your needs not only today, but in the future as well. So what can you back up with a single EverVolt system? So, it's going to depend on the home. If it's just a modest home and, especially in an area like Southern California or very mild climate where you don't have a lot of AC or heating needs, generally you almost can back up a whole house in certain situations like that. But in general, when we say essential loads, we're talking, what does a homeowner really need during an outage? And you want to do this not only because you don't want to exceed the system's capabilities of power output during an outage, but conservation is always the #1 best step anyways, right? So we're talking refrigerator, so that way the food doesn't go bad. Your lighting, we've got to be able to see. Garage door, want to be able to get out without having to manually lift that thing. Internet connection, vital, and then all of your electronic devices, and of course, coffee. Now, what can you do with 2 or more EverVolt systems? This is when we start getting into some, maybe small AC units, well and pool pumps, electric vehicles on a low charge setting, additional heating elements, things like that. And we'll kind of get into more specifics on the thought behind what can or can't be done here later. So the sales strategy, right? So there's different kind of philosophies we've seen people be successful with in the field. So kind of method #1 is this is the essential strategy, or the kind of the emergency backup situation where you're installing a single EverVolt Standard or Plus. You have a sub panel, and then you're going to relocate. We say 4 to 6 on this slide, but I mean, really, oftentimes you can put all single pole breakers on it, just depending on the house and the customer is cognizant of what they're doing during an outage. So you're going to take your single pole breakers, put them on the backed up loads panel, and call it a day. Pretty simple for kind of a average house. Now, method #2, this is really key and critical if you're going to be doing any of the larger appliances or things like pumps and AC units. Is yes, you can grab the nameplate ratings on things or look up the make and model and get all the specs on it. But really what's key is if you can and do a site survey, clamp onto the wire and measure what that startup current is, open the Sub-Zero refrigerator and see how much current is drawn at the start when that kicks on, things like that. And this is going to be really key in understanding, okay, how many amps are going to start up at once? And then will the amperage exceed what a single or 2 or 3 EverVolt systems can provide? The most fun and laborious method, and this is generally kind of really the off-grid method, is a plug load analysis. So you're looking at everything in the house, you're estimating, how many hours they're going to run, so what can be on at once, and then you're really dialing in the specific size of that system needed from the homeowner. And then method #4, and we'll talk a little bit more about this in a minute, but you can install a load control device. So we actually offer a package with our system that has a load control device. So this allows the homeowner and the installer to kind of automatically or remotely manage loads on that backed up panel. So a common question from homeowners is, okay, how long am I going to be able to run my house in an outage? And of course, the answer is it depends, right? We've talked about all these different variables and factors, but from, if you're at the kitchen table and you're just, trying to educate the homeowner at the point of sale, and you can kind of get a general idea of, what they are, what kind of house it is, what size it is, and things like that. A very simple way to look at it is what you see here. So an EverVolt Plus, as we mentioned, is 17 kilowatt hours of usable energy. The average home in the US consumes about 30 kilowatt hours per day. So if you have the customer's utility bill, you can obviously grab that on an annual average, and then you can do the math here. So we're getting 14 hours of backup in this particular average house with an EverVolt Plus. Now, of course, you want to put at least some safety factor on that because of the differences in houses and locations and climates and all of that. So we reduced it to 9 hours of backup. So kind of rule of thumb, if you have an average house and you're installing an EverVolt Plus, 9 hours of backup is a very basic way to deliver it to the homeowner. But again, you want to go further and beyond that and really understand if there are any bigger loads or what their true desires are, and set the expectations at a deeper level. So to kind of summarize, keep it simple. AC coupled, again, is a great way to go. I mean, DC coupled certainly has its advantages, and we think it's a great method, and that's why we offer it. But AC coupled is so simple. So if you have maybe a less experienced team, or a team that's very refined on their solar offering, AC coupled is a great way just to kind of have it, start offering energy storage to your customers, because you can keep kind of the status quo and then simply add a adder to that system. And again, this is not your price, or this is not the price you guys get from Soligent, and this is not necessarily the price to the homeowner. This is just a generic price that we're throwing up here. So again, reach out to your Soligent rep for your equipment pricing. How big of a system can I afford? Rule of thumb, again, buy as much battery as possible. And then keep the design simple. Again, if you have an EverVolt system, relocate, most, if not all of the single pole breakers, the 20 amp circuits. And then also you can just say, well, we're going to install a load control device. So that way we don't have to really think it through and have that discussion with the homeowner of which loads are we going to be able to back up in an outage, because we can change it after the fact and give that power to the homeowner. So the myth of whole home backup. This was a good article by Barry Cinnamon almost a year ago now, and it's still true to this day. And these are just some clips that you'll see online, kind of what I was mentioning. A homeowner will go on, start going down the rabbit hole, and read things like this: power everything. Sounds awesome. Uninterrupted power for the entire home, right? This is amazing. So again, we want to set the right expectations and walk them back from this ledge that homeowners tend to be on, and really let them understand what their system is going to be capable of. And a great way to do that is say, okay, Mr. and Mrs. Homeowner, you've got a 200 amp main service panel with one EverVolt system, or if you guys are offering these other companies out there, you can see you're going to have somewhere in the range of 20 to 30 amps of continuous power, right? So backing up 200 amps with 20 to 30 amps, I think anybody's going to be able to see it's just not realistic, right? So there's going to have to be significant either load management or just that expectation that you're not going to be able to back up all your circuits. So we kind of talked about this already, but again, you can start backing up anytime the homeowner's saying AC units, pumps, electric vehicles. Automatically just start at the 2 or 3 plus EverVolt systems. Don't even talk about a single EverVolt system at that point. Of course, there are some exceptions, but that'll come with, I think, experience. So this is another kind of sample homeowner matrix. So with the partial home standard, you can call it, this is not our official name, but just ideas to give you guys. These are the specs on the system, and we're talking, 5 to 10 single pole breakers. So your emergency kit, your partial home plus, and this is 2 EverVolt systems. So you can power many circuits, from your main service panel. So all single pole breakers, some 240 volt appliances. And then, here is, generally for a modest size home or home, you can start to call this as a whole home, because you can see the power here starts to get pretty significant. So onto the load management. So we do have a partnership with Span. So if those of you guys are familiar, it's a great product. There's a lot of really cool advantages to it, but this basically allows you to shed the loads automatically that you don't need. So Span is, as you see in the picture here, it's a unit that will fully replace that main service panel. So from the perspective of if you're already upgrading that main service panel in an installation, it makes a lot of sense. If you're not upgrading the main service panel installation, we think it still makes a lot of sense. It will, of course, upfront be a little bit more expensive, but for 10 years of usage or longer of usage for that home, the upfront cost for sure outweighs it. So Span, it can help reduce it because number one, you're eliminating the backed up loads panel. So in those basic diagrams you saw earlier, now you don't have to even have space on the wall for a separate sub panel. You don't have to talk to the homeowner about which circuits you're going to relocate. And of course you have the labor associated with pulling circuits from a main service panel. A lot of times that backed up loads panel is a far distance from the main service panel. And so it can create some challenges, or if Sometimes there's, sub panels and whatnot throughout the house. So it can start to get really challenging in that sense. This is something I don't think we've mentioned yet, but you do have the ability to install larger PV arrays. So the limitations on PV size I mentioned earlier kind of go away when you do a load control device like SPAN, because in an off-grid situation, you can simply turn that additional PV circuit off. So that's, again, assuming your entire PV array is not on a single circuit. And then also here, going back to the, consumption is always the best methodology. Providing what the homeowner will now see with SPAN is the individual circuit level consumption and monitoring of their home. So they'll be able to kind of see which rooms are using more power throughout the day, which appliances or devices, and ideally take steps not only when the grid is off, but when the grid's there, to start to reduce their energy consumption and their energy reliance on the grid. So this is a quick view into the application for SPAN here, and you can see it's very nice. You've got, in an off-grid mode, you can set what your must-have, circuit breakers are, your nice-to-have circuit breakers, and then your non-essential. And then you can set different things. For example, if the batteries reach 50% state of charge, you want to, eliminate some of the nice-to-haves and really go into ultra-conservative mode, things like that. So it's very smart. And it can grow with the home over time. So oftentimes homeowners are, either literally their families are adding more people and growing, so their electricity usage increases, or they're adding electric vehicles, or different things like that as we kind of move oftentimes to more electrification in the home. So one thing that we've seen folks do to kind of reduce the startup current, because kind of the real deal breaker in using air conditioning units or pumps is that inrush current, or kind of the startup current when it first kicks on. So for an AC unit, you can use what's called a single phase soft starter. And so this will help to more slowly ramp up that current, as opposed to just starting it right away and then having that high current. So for example, instead of having a motor draw 40 amps, maybe by installing one of these, it'll reduce it to 30 amps or lower. So it'll help on that sense. And then similarly for pumps, you can install these. An example here is just a drive unit here. This particular one looks like from Franklin. So I know this was on an actual job that we had done. And the results were quite impressive. You can see the initial draw from that well pump was 37 amps. And then the installer put this drive unit in, and it reduced it to 5 amps. So it's actually pretty funny for this site. They had originally installed 2 EverVolt systems, thinking that they needed to handle that 37 amps. And then after installing this and measuring the current, they decided to remove one of the EverVolt systems and save a little bit of money, knowing that they didn't need that much current any longer. So what are some kind of common challenges in closing the sale? Confusion, and so again, keep it simple. Use a consultative approach, but don't get too far in the weeds. Homeowners, they, again, they've got the internet at their fingertips, so they're diving down all these rabbit holes and trying to get educated on this information, but it's not simple. Even to us industry veterans, it's not simple. So try to keep your approach simple. Use tried and true methods. Don't really, try and get too detailed in exactly right sizing systems and talking about different specs with homeowners. Number 2 challenge, I'd say, is probably the incorrect expectations that are generally set by others, whether that's other installers that you're competing against, other energy system manufacturers, articles that folks are reading online, things like that. We want to, number 1, set the expectations with the homeowner, like we've talked about here, and bring them to a realistic level. And then another common challenge is just too many options, whether that's, they've gotten multiple quotes from multiple installers, or they're trying to find, who's got the best energy storage system, and they do a lot of research and kind of get confused with specs and, kilowatt hours versus kilowatts versus amps. And it gets very confusing for a homeowner, and they can generally get paralyzed then and not make decisions. So from an installer's perspective, keep your product offering simple. Don't go to a homeowner and say, we've got, 5 different energy storage products we're going to offer, obviously. And then a great simple thing, is provide a system solution from a trusted brand. Even though we do make the batteries and we're a leading battery manufacturer out there, we generally don't tell people to lead with that to a homeowner unless they get into that for specific reasons. The system, whether in the solar and the storage system, is coming from Panasonic, so it's a trusted brand. We're going to be around to back any problems down the line. Insufficient financing is obviously a deal breaker in energy storage, where the homeowner, because they're in California, for example, in the PSPS events and things like that, where your power is shut off, or wildfires, hurricanes, things like that, you're going to be willing to spend a little bit more money to have your home and your family protected in that sense. And something we've done recently is we've launched a financing program in a partnership here. So feel free to check that out with your Panasonic sales representative. They'd be happy to help you out with that. And so again, kind of to summarize, what sets EverVolt apart from the rest? We've got a full solar and energy storage system for those that don't know, we're over 100 years old. We've been doing batteries for almost as long as that. Designed for maximum resiliency. So our batteries, if one were to fail, you saw that there's 6 or 4 packs inside of a system. If one were to fail, the remainder of them would be connected and running, so the homeowner wouldn't necessarily lose power. We've got both AC and DC coupled options. Maybe something that you guys hopefully have taken away is we're not trying to force down a specific system architecture or kind of change your sales model and design approach. We want to, let you guys customize it for your market, for your business, what makes sense, and we can provide, the solutions for you. Something else fairly unique is each battery pack is only 55 pounds. So, something that we will for sure see 10 plus years down the line is a massive battery recycling effort and trying to get these things out of homes into recyclers. So having a battery pack that's only 55 pounds is, it's going to really, really reap the rewards down the line. And bankability, right? This is one of the most expensive things a homeowner, maybe the most expensive thing next to a mortgage or home purchase. So, you want to make sure that it's with a trusted bankable company if you're putting that much money into that system. All right, so I think we're doing pretty good on time. So this is going to be a questionable section. We will save about 10 minutes, I think, at the end here to answer and address your questions. But I think this is kind of something that comes up a lot. So, battery chemistry, depending on the market, it can or cannot be a hot topic. But basically, some homeowners are more interested in the chemistry behind things than others. From our approach, we generally don't talk chemistry. And, one of the main reasons for that is in other more mature industries, like, automobiles and cell phones, laptops, things like that. A homeowner, you're not walking into the store and asking, well, what's the battery chemistry in this one versus that one? You just want to make sure you're getting a good product, a high quality product, a powerful product, and a safe product. So, this chemistry topic, my prediction is it's going to disappear over the next several years, but we'll see. So what drives the chemistry, right? It's electric vehicles, and that's the bottom line. You can see here our little stationary storage world, even though it's probably a big part of our as in a solar respect, a big part of our universe. It's a very small part of the global overall battery production universe. So kind of the point to this is whenever somebody says, what's the next greatest battery technology coming down the line? My basic answer is what's in EVs, because that's going to be coming next to stationary storage for the most part, is a pretty safe bet. And so for those that do have, concern with some of the mineral or the materials and the elements inside of different batteries, one of the hot topics is obviously cobalt. This is a public article, but you can see that, we're increasing density. We're lowering cobalt in our battery cells. And you can see the total amount here of cobalt used in Panasonic cylindrical automotive batteries is less than 2% of global demand. So, I think it's for those customers that are concerned with this, that is a pretty powerful statement that even though we are one of the largest battery manufacturers globally, we have a very small, our own personal footprints in that space. And actually, we are aiming for 0 cobalt in cells like others as well. We've already managed that in our R&D lab. So commercializing this is really the next key step. So there are very appropriate measures being taken. Another reason why Panasonic, so this is just a generic test that was done by DNVGL actually, so a third-party lab. We didn't participate in this. I literally just grabbed this from their report. So, take it for what it is, but the main takeaway is that these are all different battery manufacturers. And you can see that kind of how they perform is all over the map. So really the takeaway is there's no defined set criteria yet from, UL or from others that are really, making sure that whatever battery specs are provided are really going to the homeowner on all levels, or I guess I should say on an equal playing field, and that all batteries are going to perform exactly based on their nameplate specs. So the best advice we can give from this is, because it is such a young field, again, choosing a battery manufacturer that's been around a long time, that has the R&D and know-how to actually design a battery that's going to perform and last and be safe is probably one of the most, if not the most important aspect in choosing an energy storage system. Again, another topic, and again, I suspect this to dissipate and disappear by the wayside over time, similar to how we have, natural gas in our homes and combustible tanks of fuel in our cars. Nobody really talks about that anymore. I don't know how long it's been, but certainly not in my lifetime. I don't think I've heard anybody be concerned about those types of devices in homes and in cars. And really, because, any concentrated source of energy, and it's kind of the definition of that, is supposed to have a ton of energy packed into it. So there's going to be some potential things that can happen to that, right? What really is important is that the system designer and the manufacturer of the product knows exactly how to design that system for a safe and code compliant installation to make sure that it is safe. Because certainly, you wouldn't want to have even a natural gas appliance in your home if you knew that it wasn't designed by somebody following the codes and standards and making sure that it's a safe product. So, again, and this is from DNVGL's report, basically saying that you can't say that one particular battery chemistry is superior than another. So these are our warranty metrics that come with EverVolt. The standard and plus, we talk in throughput, again, because everybody seems to always want to talk cycles, but maybe one of the easiest ways to explain it is on a very basic level. If homeowner A is setting their battery reserve to 50%, and then their next door neighbor, who maybe has the exact same usage patterns, but is setting their battery reserve at 0%, which means they're using the battery every single day, fully discharged. How does that work in the cycle terminology? So draining at 50%, then charging at 50%, that could be considered a cycle, because that's kind of what they're doing per day. Versus the next door neighbor who's draining at 100% and then filling it up to 100%. That could also be considered a cycle. And then the real main reason is because cycles just don't account for degradation. So on day one, you're going to have that 17 kilowatt hours of usable energy that comes with EverVolt. On year 5 or year 8 or year 15, you're obviously not going to have 17 kilowatt hours, just like your cell phone or laptop battery degrades over time. So a cycle doesn't take that into account. So we want to speak in, again, energy. This is what you pay the utility. This is what's going to have real world value to your bottom line, is how many kilowatt hours you're using or producing or storing in your battery. So this is what you see here, and it's similar to like a car, how many miles you have in that warranty. And then the capacity we guarantee is a minimum 60% at the end of the warranty period. And for those that have been working with Panasonic for a long time, you guys will know that we're generally one of the more conservative, if not the most conservative company out there. So I kind of always like to preface this with, that's the minimum. Using it in a normal kind of typical environment, I think we'd expect much, much more beyond that to be available at the end of the warranty period. But like all things, it's going to depend exactly on how the homeowner uses it, how much they're discharging every day, the climate that you're in, what operating mode you're in. So a whole host of factors will come into play as to exactly how much capacity that homeowner is going to have at the end of the warranty period. This is a quick look at our mobile app. It's very basic, very easy and clean to read. Gives the homeowner basic visibility into what's happening in their home, and then also allows them to change the modes between backup, self-supply, savings, reserve level, and kind of see some historical production and numbers there. And yeah, just something great. Again, we just want to wrap up because this is, I think, a trend that we're starting to see as well. But to the homeowner, it's a lot of money that they're spending. So offering a single, bankable, trustworthy manufacturer is really important. So we think that it's only helps that homeowner build trust in you guys and everybody. So yeah, it's just a very simple way to make the sale and product offering. Very important. We do have a certified installer training course. This is mandatory. This is mandatory. This is mandatory. I'm sorry, I have to just keep saying that over and over and over again. Please, please take the course. Please do not, even veterans of energy storage systems, you've been doing off-grid for years. This is, every system has its subtleties. Take the course, send us your wiring diagram, let us review it before scheduling the installation, before setting the expectations of when the system's going to be ready on your first installation with EverVolt. We just want to make sure that we are setting you guys up for success. I think 99% of errors in the field can be attributed to not doing this. So it's very important. Get certified and ask us any questions before designing or after design, but certainly before installing, and send us the wiring diagram. It's a great service that we're happy to help you guys out with. This is a map of Panasonic kind of regional sales managers. So your resources, of course, you always want to reach out to your Soligent representative. They can help you out with any items on our EverVolt system. If you want to also reach out to Panasonic, or if you need additional support, here's also your Panasonic sales representative contact. And just kind of real concrete takeaway steps. Again, I can't say this enough, become EverVolt certified. And this goes for Soligent folks that are online as well. Hopefully you guys are all certified. Consult with your Panasonic and Soligent sales rep for any questions. Go out and sell a system, right? And it's always recommended you consult with us. We're happy to help with any of that. And then once you sell it, or hopefully before you sell it, or if you're in the middle of selling it, send the wiring diagram to us after you become certified. And then upon approval, schedule the installation date, and then send that coordinate, with your Panasonic and Soligent rep on that installation date. Again, for your first installation, especially if it's your first energy storage installation, but even if it's just your first EverVolt installation, we really want to help you guys out and make sure that it's successful. So keep us, don't be afraid to reach out. All right, I apologize. I think we're 3 minutes over, but yeah, hopefully that was good information for you guys. So we can, I guess, open up the floor for questions.